Therefore, I have two triangles ABC and DAF such that they have correspondingly equal angles. That is, angle A equals angle D, and angle B equals angle E, and angle C equals angle F. So when the corresponding angles are equal, then the theorem statement says that the sides opposite to those equal angles will be in same ratio. That is, if the side opposite to A is BC and the side opposite to D is EF, which are the sides opposite to equal angles, then BC by EF will be equal to AC by DF equal to AB by DE, which we are going to prove using the correspondingly equal angle properties. So in order to do that, what I am going to do is, first initially, I take the distance AB and cut an arc on the line segment DE such that I get a point P which is exactly equal to AB. Therefore, AB equal to DP. Similarly, I take AC and that measurement I take here as DQ so that I get a triangle with this equals this and this equals this. Therefore, if I take these two triangles, I get triangle DPQ and ABC are two triangles such that AB is equal to DP and AC equal to DQ, and corresponding angles are equal. So let's derive this and see what we get in comparing these two triangles. So let's see the construction and come with the actual proof of this AAA criterion for similarity of triangles. So to continue with the theorem, now I have few constructions which I need to make here. The construction here is so mark a point on DE such that AB equal to DP and AC equals DQ are such that I get 2 points P and Q, implies P and Q are points on DE and DF respectively. Therefore, join P and Q. So I join the points P and Q so that I get two triangles ABC and DPQ correspondingly. So using this construction, the proof what I have out here is, to start with, initially I have that angle A equals angle D, angle A equals angle D, and AB equals AP, so DP, this is D, and AC equals DQ. Therefore, I get AC equals DQ such that I have one angle, one side, and one more side correspondingly equal, which implies this is SAS congruency. We have already dealt with congruency of triangles where side angle side congruency applies for these two triangles. Therefore, using SAS congruency, I can say that triangle ABC is congruent to triangle DPQ using since by SAS congruency property. We get these two triangles similar. Now, when two triangles are congruent, then the corresponding angles and corresponding sides are same. Therefore, this will be equal to this and this will be equal to this. That is, angle B equal to angle P and angle C equal to angle Q here. Because these two are congruent, that implies angle B is equal to angle P and angle C equals angle Q, as I can see here. Because of congruency, corresponding sides and corresponding angles are respectively equal. Now connecting this, we already know that angle B is equal to angle E, and angle P, angle B equal to angle P and angle B equal to angle E implies angle P is equal to angle E by transitive property. So if I just compare angle B, which is equal to angle P, and angle B is also equal to angle E, implies angle B is equal to angle P is equal to angle E, is what I get as transitive property. Similarly, my angle C is equal to angle Q and my angle C is equal to angle F. Therefore, angle Q is equal to angle F by transitivity. Therefore, here my angle C, which is equal to angle Q, is equal to angle F, is what I get on the whole using the transitivity property. Now, when I take this pair of the equal angles, I clearly see that angle P is equal to angle E implies the corresponding angles are equal, or angle Q is equal to angle F implies the corresponding angles are equal. So when corresponding angles are equal, this line must be parallel to this, is the property we have in parallel lines. So therefore, angle P equal to angle E and angle Q equal to angle F implies corresponding angles are equal. So when corresponding angles are equal, we have the two lines parallel by parallelity condition. Now, since the corresponding angles are equal, therefore that implies PQ is parallel to EF in triangle DEF. Now, when these two are parallel, then by basic proportionality theorem, if the line is parallel to the third side, then that parallel line will divide the other two sides in the same ratio, is what we have seen in basic proportionality theorem. Therefore, this divides in the same ratio implies dP by PE is equal to dQ by QF by basic proportionality theorem, is what I get when I divide this by this and this by this. So therefore, I get by basic proportionality theorem dP by PE is equal to dQ by QF, so that on interchanging the numerator and denominator, I can remodify the fraction as PE by dP equally with QF by dQ, is what I get when I interchange the numerators and denominators, maintaining the equality to be same. Now here I have PE, which I clearly identify as DE minus dP is PE, because the whole of DE minus this dP gives me the PE. Therefore, I get this as PE is substituted with DE minus dP by dP, is what I get on the left hand side. Similarly, my QF is whole of DF minus DQ gives me QF. Therefore, the fraction of QF is substituted with the whole of DF minus DQ by DQ, is what I get when I subtract the line segment DE with PE. I get this and this respectively. Now this on splitting of fractions, that is when I split this separately as DE by dP and this as dP by dP, because I split the fractions respectively for the first term and the second term, I get this for the left hand side. Similarly, on the right hand side, when I split the fraction, I get dF by dQ minus dQ by dQ, so that this becomes dF by dQ minus dQ by dQ, is what we get in the fraction. Now here I can cancel these two because they are equal, and therefore this finally reduces to the fraction dE by dP minus 1 equals dF by dQ minus 1 on the right hand side, so that this also gets cancelled And finally, I get dE by dP, that is equal to dF by dQ. dQ. So I get here dE by dP equals to dF by dQ is one more way of understanding the corresponding sides being in same ratio, because when a line divides the third side parallelly, being parallel, dP by PE is equal to dQ by QF is equally true as dP by DE equal to dQ by dF as a corollary of the extended basic proportionality theorem. So when I got dE by dP equal to dF by dQ, then immediately my dP is equal to AB, as I have taken these two sides equal. Therefore, in place of dP, I can substitute AB because both the sides are equal. So in place of dP, I get dE by AB because my dP is equal to AB. Similarly, my dQ is equal to AC. Therefore, dQ replaces with AC will be dF by AC is what I get in substitution of the equal segments. Now, interchanging the numerators and denominators, let's see what we get continued from there. So, continuing from the theorem, I interchange the numerators and denominators of the ratios which have been obtained so that I get AB by DE equal to AC by DF is what I get when I interchange the numerators and denominators. So similarly, if I take, obviously the third side will also be in same ratio, because if I take the same parallel property in this manner, if I draw a parallel line like this and then I use the similar properties, I can show that BC by EF is equal to the three fractions. Therefore, proceeding similarly, I get AB by DE, which is also equal to BC by EF is what I get. BC by EF. Therefore, combining these two, I can show that overall that implies the side AB by the side DE of the bigger triangle and the side BC by EF and the side AC by DF are in same ratio. That implies corresponding sides are in same ratio. Therefore, the two triangles are similar. So therefore, here we understand that if the corresponding angles are equal, then I have proved that from the corresponding angles A equal to D, angle B equal to E, and angle C equal to F, we have proved that the corresponding sides are in same ratio. Therefore, by definition of similarity, which says that if the corresponding angles are equal and the corresponding sides are in same ratio, triangle ABC is very much similar to triangle DEF. The two triangles are similar because their corresponding angles are equal and hence their corresponding sides are in same ratio. So the AAA criterion for similarity of triangles makes us understand that if I have the minimum condition of the three angles, corresponding angles being equal, then obviously the corresponding sides will be in same ratio as derived in the proof, and hence by definition of similarity, both the properties, property 1, the corresponding angles are equal, and property 2, the corresponding sides are in same ratio, will be satisfied, and hence the two triangles are similar. Now it is very important to note that for a AAA similarity can be reduced to a AA similarity, because the restriction to AA similarity is because if two corresponding angles are equal in two triangles, then obviously the third angle will also be equal. As I can take, for example, say two triangles ABC and the other triangle DEF, in which this angle is equal to this and angle B is equal to this, but my angle C is not equal to angle F. So let's see if based on these two angles the third angle is same, is what we are going to prove. So let me take this as angle X and this as angle Y, and then here I clearly understand that angle A equals angle D and angle B equals angle E, but angle C and angle F are not given to be equal. So let's try and see if the third angle can also be equal based on the minimized condition of the two angles. So now here, since angle A is equal to angle D and angle B is equal to angle E, now I can see that here angle C is nothing but 180 minus angle A plus angle B, because sum of three angles of a triangle is 180. Therefore, angle C will be 180 minus angle A plus angle B. So that this, on further simplification, gives me 180 minus angle A, which is equal to angle D, can be substituted for angle D in the first place, and angle B, which is equal to angle E, can be substituted for angle E in place of A plus B. Now this clearly gives me the picture that 180 minus angle D plus angle E will be angle F, because sum of three angles of a triangle is 180. Therefore, 180 minus angle D plus angle E will be strictly angle F, because sum of three angles is 180. Therefore, this concludes that angle C is equal to angle F. So therefore, if the two angles are correspondingly equal, then obviously the third angle will be equal, and hence the triple A similarity can be restricted to being called as double A similarity. So therefore, this proof makes us understand that, therefore, triple A similarity restricts or reduces to understanding that if the double A similarity holds, then the whole of the properties of triple A criterion hold. Reduced to double A criterion for similarity of triangles. Therefore, my statement says that if two angles of one triangle are correspondingly equal to two angles of the other triangle, then there will be the sides which are in same ratio, and hence the two triangles are similar. Therefore, the proof can extend only restricted to two angles being equal, but not the three angles. So triple A similarity is restricted to double A similarity from this proof as evidence. Now next is the triple S criterion, as we have seen the triple A criterion. Now triple S criterion is said to be the converse of triple A criterion. So I identify this as converse of triple A criterion, in the sense that my triple A criterion stated that if the corresponding angles of one triangle are equal to the corresponding angles of the other triangle, then the two triangles will have their sides in the same ratio. Now here, conversely, we assume that the corresponding sides of one triangle are proportional to the corresponding sides of the other triangle, then we prove that the corresponding angles are equal in the reverse process of triple A criterion. And finally, we say that the two triangles are similar, is what we are going to see in triple S criterion. So to start with, the triple S criterion for similarity of triangles, the statement says that if the corresponding sides of the two triangles are in same ratio, then the criterion says their corresponding angles are equal based on their corresponding sides. Then their corresponding angles are equal, and hence the two triangles are similar. The two triangles are similar is what the statement makes for S criterion. So let's see in brief about its proof, but initially, to start with the given part of the theorem, I have the corresponding sides. Say for example, I take the triangles ABC and DEF. It is given that the corresponding sides are in same ratio, that is AB by DE is given to be BC by EF equals AC by DF. BC by EF, that equals AC by DF, is what we have as the corresponding sides equal. Now next, let's see what are the different constructions I need to make before proceeding for the proof of the theorem. So construction to be followed with. So let's see the construction in the two triangles ABC and DEF. Now here, let me take a point P on DE such that this length is equal to this length, that is AB is equal to DP. Similarly, I take a point on Q such that AC is equal to DQ. Now once I got the points P and Q, I just join P and Q so that I get triangle DPQ in reflection of triangle ABC. So here the construction is let P be a point on DE such that AB equals DP, and similarly let Q be a point on DF such that AC equals DQ is what I have taken as the construction. Then finally I join PQ. So joining PQ, I get two triangles ABC and DPQ. So let's see how we can proceed with the proof of the theorem to be followed with. Now to start with the proof, clearly let's take the given condition that the corresponding sides are in same ratio. Therefore, when I have the corresponding sides of triangle ABC and DEF, AB by DE is equal to BC by EF, which is equal to AC by DF. Now, as I take these two conditions, I clearly understand that my AB is equal to DP from the construction. Therefore, in place of AB, I substitute the equal length DP. So this gives me DP by DE is equal. Similarly, my length AC is equal to DQ, so I substitute the segment DQ in place of AC out here, and the denominator remains the same. So I have dP by dE is equal to dQ by dF, which is nothing but the basic proportionality theorem, the extension of basic proportionality theorem. Therefore, when P and Q divide this in the same ratio, PQ is parallel to EF is what we get. Now that implies PQ is parallel to EF by basic proportionality theorem. is what I get in parallel. Now once I prove that the line PQ is parallel to EF, then immediately it follows with the corresponding angles being equal in the parallel lines. Therefore, this will be equal to this, and this equal to this. Therefore, my angle P will be equal to angle E, and my angle Q will be equal to angle F from corresponding angles. That implies angle P equals angle E and angle Q equals angle F, since they are corresponding angles are equal in parallel lines. Therefore, the corresponding angles, this and this, are equal, such that this equals this and this equals this. Now these two angles which are equal, I would like to take this as equation 1, because we use this in the later part of the proof. So these two angles equal I take as equation 1 and continue with the proof. Therefore, continuing with the proof, I have the basic proportionality theorem applied in triangle DEF, which gives me dP by dE, which is equal to dQ by dF which equals PQ by EF. Is what we get as three basic ratios equal. Now, as I see clearly here, I also have that AB by DE from the given statement, the corresponding sides are in same ratio. Also, I have the line segment AB by DE is equal to BC by EF, or I take AC by DF is equal to EC BC by EF, is what I get from the two different concepts. This is by basic proportionality theorem, and this is since given. So from the given concept and by using the basic proportionality theorem, I get this equals this. Now, as I have AB equals dP, I can substitute this AB as dP by dE, which is AC, which is equal to dQ. Therefore, in place of AC, I substitute this as dQ is equal to dF, which becomes BC by EF. But here, because dP by dE and dQ by dF is nothing but this, therefore this can be substituted for PQ by EF, is what I get in the case of these two ratios. So when AB is substituted for dP because they are equal, and AC is substituted for dQ because they are equal, this ratio comes back to the original ratio, which is PQ by EF. Therefore, my third ratio, BC by EF, will be equal to PQ by EF, is what I get finally from the ratio. This is all from since AB equals dP and AC equals dQ, is what I get. Now similarly, when I take the last two pairs, I see that because the denominator EF is equal, therefore that implies BC is strictly equal to PQ. Because the denominators are same, this and this will be equal, such that my BC equals PQ out here. So therefore, I understand that all of the corresponding sides are equal. That means by SSS congruency, we have ABC triangle is congruent to triangle DPQ. So the congruency will help us in finding the corresponding angles equal.